Hello there, it's Alana. I'm back to help you with problem 5.3, number 21 from the study plan and from the textbook. Of course, who knows what it is in your actual assignment or problem, etc. Okay, I'm going to do the example. So let me click on this and maximize it. So for a parallel structure of identical components, and that's code for, to be honest with you, electrical stuff a lot of the times, or you'll have mechanical parts inside like a computer, that kind of thing, switches, that kind of thing. Anyway, the system can succeed if at least one of the components succeeds. So think of it like your Christmas tree lights. You ever have those lights that, it's okay if one of the lights goes out, the lights still run, right? So if at least one of the lights still succeeds, then something gets lit up. That's sort of what this is. So assume the components fail independently of each other, and that each component has a 0.09 probability of failure. So, for example, if you think about the Christmas lights, each light bulb is independent of each other, and there's a 0.09 probability of failure. Okay? All right, would it be unusual to observe one component fail, right? One light bulb go out. Two components. Okay, so one component failing, well, there's a 0.09 chance of failing, right? So that's not unusual at all. Remember, unusual is 5% or less, okay? So that's not unusual. As a matter of fact, I'll put this in Excel just so you can see. So A, the probability of failure for one component is equal to 0.09, right? And this is not unusual, not unusual. I can't spell, there we go, because it is more than 0.05. Okay, next, part B. What about two components? I think that's part B. Let's go back. Continue. See, 5%. Good. One component failure is 0.09, etc., etc., etc. Oh, two components is still part of A. So let's do it. So this was A number 1. Then the probability of failure for two components. Now remember, they're independent of each other, right? So remember, the probability of E and F, failure and failure, is the probability of E times probability of F. See that? They've got the little formula right there. So let me write that out for you guys. So this would be equal to the probability of failure for first component and failure for second component. Okay? Well, that's equal to 0.09 squared, right? Actually, I should probably do a cell reference thing. Equals that cell squared, because you want the first component to fail and the second component to fail, right? And so you multiply because they're independent of each other. That's why I'm squaring it. So if you want to think of it this way, I'm multiplying 0.09 times 0.09. Okay, well, that is unusual because it is less than or equal to, but less than 0.05. 0.05 itself counts as unusual, I believe, in our textbook. Let me double check that. Oh, no, 0.05 does not. It's just less than is unusual. So if it's equal to 0.05, that's not considered unusual for our book. Some books count it, some books don't. Our book does not. Oops, I'm sorry, I'm on the wrong window. All right, let's see what we want. What is the probability that a parallel structure with two identical components will succeed? Oh, okay. So remember, to succeed, you need at least one of them. So let me bring that up. Okay, part B. We want the probability that the structure succeeds, right? That something gets lit up on this Christmas tree. So that's equal to the probability that at least one of them succeeds, right? Because they said if at least one thing succeeds, then the structure succeeds. Okay, but there's those magical words, at least one, at least one. So whenever you want to find the probability of at least one, you do 1 minus the probability of none succeeding, right? Oh, it's not going to like that, sorry, because of the equal sign in front and it's not a formula, so let me do it this way. Okay, so if you want at least one to succeed, that means you want to find the chances that nothing succeeds and take it away from one. You're looking for the complement. Let me see if I can show you why. So what could you have? You have two components. It's like a string with two light bulbs. You can have succeed, succeed. You could have succeed, fail. You could have fail, succeed, and you could have fail, fail, right? So they want at least one succeeding. They want all three of these added up. So it's easier just to find fail, fail, and take it away from one. That's what you're going to do. So you're going to find 1 minus the probability of fail, 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 and fail. Ah, but we already did find that. It's 1 minus, and we found it right here, 0.0081. So the chances of it succeeding is 0.9919. Okay, so these are our answers. Not unusual, unusual, etc. All right. Okay, so then let's see what else they need. See if I did that right. We'll double check. See, 1 minus probability V. See, 0.9919. Haha, I knew what I was doing. All right, how many components would be needed in the structure so that the system will succeed in greater than, or excuse me, the probability the system will succeed is greater than 0.99999. Okay, now they're going to show you this whole way that involves logarithms, and that's all well and good, but I'm assuming most people haven't seen logarithms in a while, so let me come up with this in a different way. Hold on. So I'm going to do this by trial and error a little bit. So here's what we're going to do. We're going to say we have one component, two components. Oh, yeah, look at this. Number of components. Okay? So 1, 2, 3, 4, 5, 6. As a matter of fact, you can just, let's do this faster. Equals that guy plus 1, enter. So when I drag it down, it gives me that. And I can always drag further if I need to. Okay, so then I want to know the probability of all fail. Okay, so this would be equal to 0.09 to the 1 power, B10. And then if I drag it down, it should be, see, 0.0081, because that's to the 2 power, because there's two components that are going to fail. And if I drag it down, there's three components, right? 0.09 times 0.09 times 0.09, and so on. Okay, so I can drag it down. I don't think I'll need to go this far, but that's okay. All right, so then what's the probability that at least, so succeed, so system, structure, whatever it was called, structure system succeeds. That's equal to 1 minus the probability that they all fail, right? None succeeding. I guess I could have put that up here. None succeeding, which is 1 minus the probability of all fail, right? Because if neither one of them succeeds, then they both fail. But we're just taking it and we're kicking it up a notch. It's 1 minus that guy. So you can see the one we already found is right here for 2, 0.91919. But then you could expand it and kind of keep dragging it down. And what you're looking for is the first one that's over the whatever threshold they want. Ah, wrong window. So they want 1, 2, 3, 4 nines, 0.9999. So you need to go to the one that is past 4, excuse me, I can't talk, 4 nines in the number over here. And you can see, okay, at 3, we're at 0.999. And at 4, we've hit 0.9999. So there it is, right there, 4. You would round up, right? So there's your answer for C. Now there is another way to do it, obviously, that involves algebra, and that's what they're doing here with a logarithm. See, they come up with 3.82, and they would round that to 4, right? Just like we did. So we know it happens somewhere between 3 and 4 because you can see it. And the threshold they wanted was 4 nines, so that's the 4. Now if they wanted 5 nines, that would actually be 5 because that you take that long to hit it. 6 nines would be 6, 7 nines would be 7. That just kind of worked out that way. Nice. All right, let's see if there's anything else here. Oh, we're all done with that problem. Okay, so let me see if I can double check things for you. First part was just, is it, failure, 0.09. 2 failures, that's fail and fail. I guess I could just say equals the probability of fail, fail, right? Fail, fail is fail on the first, fail on the second. So you multiply 0.09 times 0.09, you get 0.0081. Then the structure succeeds is 1 minus the probability of failure, because you're trying to get all the successes added up. So you find the one where they fail altogether and then take it away from 1, and that's what we got right here. And then for C, you're just kind of expanding on that theme. You take that same idea that got us the 0.9919 and you kind of expand upon it for 3, 4, 5, 6, 7, 8 components and so on. Okay. So you say, all right, let's find the probability of fail, 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 right? All failing, 0.09 to whatever power. And then you take it away from 1, and when it reaches the threshold you wanted, there you go, you've got it. All right, I hope that helps with that problem. See you later.